guys, this is the 5-through video part 3. I just have one example I'm going to do in this one, but we're going to use something called the second derivative test. And so basically, if we know that a function is twice differentiable and the second derivative is negative, we can say that that is a local max. If the second derivative is positive, that's a local min. So here's some pictures to kind of depict what's happening here. So if it's concave up, we learned that last time. So if it's concave up, that's when our second derivative is positive. So if it's concave up, that has to be a local min. If it's concave down, that has to be a local max. So we can kind of take what we know about concavity and extend it to local mins and maxes. So this says use the second derivative to identify any local extreme values of this function. Okay, so we are going to find the second derivative. So I'm going to start with the first derivative and find our, critical points. So we're going to first find the derivative. So we get one derivative of cosine's negative sign, but since it's already negative, it's going to turn to plus 2 sine x. Okay, so we're going to solve this now. For when does this equal 0? Because this exists everywhere. There's never going to be a point where our derivative does not exist. Okay, subtract 1, divide by 2. Okay, so where on this interval? So on the unit circle, where do we get a y coordinate of -1/2? This happens at 7 pi over 6 and 11 pi over 6. Okay, so now because I'm looking for, I found these critical values. So if you go back here, our critical number is C. So they're saying evaluate what is f prime of C, of that critical value. If it's negative, then it's local max. If it's positive, it's local min. So I am going to evaluate using the second derivative. So I got to find the second derivative, but I'm going to evaluate these 2 points. Okay, so the second derivative is the derivative of the first derivative, which can be 0 plus 2 cosine x. Okay, so now I'm going to evaluate what is f double prime of 7 pi over 6. Okay, so if I put cosine of 7 pi over 6, I get negative root 3 over 2 times 2, which is going to be negative root 3. But regardless, that's less than 0. It's negative. Really, all I care about is the positive versus negative. So 7 pi over 6 is a local min. Okay, and then f double prime of 11 pi over 6. So if I put in 11 pi over 6, cosine of 11 pi over 6 is root 3 over 2 times 2, which is root 3. And again, that's positive. So 11 pi over 6 is a local, local max. Okay. I'm sorry, you guys. I did write those backwards. Okay. Sorry. Okay, so this is concave down. Concave down, so this one is a local max. And this one is concave up, so it's a local min. Okay. Now, again, if I wanted to find the exact points, I can also evaluate what is f of 7 pi over 6, right? Put this back into the original function to see what's the y value. When I did that, I went ahead and put this as a decimal, you guys, but I got 5.397 approximately. And then when I evaluated 11 pi over 6, got approximately 4.028. So here's the local min. Here's the local max as point values. And that's it for this video. Thanks for watching.